these two vector fields are conservative. Okay, in part A, we have a vector field in R2, and in part B, we have a vector field in R3. So to show that a vector field F is in R2 is a conservative one, what we need to do is we need to use the cross partial test. So this is my vector field F. It has two components. So my first component is, let's say, P. Second component is Q. Okay, now let's apply the cross partial test. Okay, so basically we want to calculate two things. We want to calculate partial Q over partial X and partial P over partial Y. These are the two things we need to calculate. Now if these two are equal, then our vector field F is conservative. Okay. Let's calculate partial Q over partial X. So we have partial over partial X of negative x squared sine y. Now with respect to the x variable, we can treat negative sine y as a constant, and basically we have to take the derivative of x squared, which equals to 2x. So we have negative sine y times 2x. This is the value of partial Q over partial x. Next, we want to calculate partial P over partial y. My P is 2x cosine y. That is the first component of the vector field. Now with respect to the y variable, we can treat 2x as if it is a constant. So we have 2x times partial over partial y of cosine y. Derivative of cosine y with respect to the y variable is negative sine y. So you have 2x times negative sine y. As you can see, partial Q over partial x equals to negative sine y times 2x. Partial P over partial y equals to 2x times negative sine y. And therefore, partial Q over partial x equals to partial P over partial y. Hence, our vector field F, which is 2x cosine y, comma minus x squared sine y. Sine y is conservative. It's conservative vector field. Okay, now let's do part B. In part B, we have a vector field in R3. A vector field in R3. This is part B. So F is in R3, three-dimensional space. Therefore, let's calculate curl of this vector field. Curl of this vector field. So curl of F equals to gradient cross F. So this is a cross product. So in the first row, we have the standard vectors I, j, and k. And in the second row, we have partial over partial x, partial over partial y, and partial over partial c. These are the components of the gradient operator. And finally, we have the component of the vector field. 2xyc, x squared c, and x squared y. Okay. Now curl of this vector field equals to, so grad cross f equals to I times, okay, partial over partial y of x squared y minus partial over partial c of x squared c. That's the first part. Then we have this minus j times partial over partial x of x squared y minus partial over partial c of 2xyc okay. The last part plus k times partial over partial x of x squared c minus partial over partial y of 2xyc. This is the way we calculate the cross product. Okay, now let's calculate these partial derivatives. So we have I times partial over partial y of x squared y, which equals to x squared, minus partial over partial c of x squared c. So we have to take the derivative of this one with respect to the c variable, and we can treat x squared as a constant. We'll get this minus j times partial over partial x of x squared y. So we have to treat y as a constant. Then derivative of this one should be 2xy minus partial derivative of this quantity with respect to the c variable. So we can treat 2xy as a constant, and derivative of c with respect to the c variable is 1. So you will get minus 2xy. Okay, and the last part, let's say plus k times derivative of x squared c with respect to the x variable should be 2xc minus derivative of this one with respect to the y variable. Okay, so here we have a product. So 2 times x times c can be treated as if it is a constant, and derivative of y with respect to the y is 1. So you will get minus 2xc. As you can see, this equals to 0, this is 0, this is 0. So curl of f equals to the first component of this curl should be 0, the second component is 0, and the third component is 0. So we have the 0 vector. This means the given vector field f is conservative. The given vector field f is conservative. Now this means in this universe we should be able to find if a vector field f is conservative. It means we can find a scalar potential function little f. So there exists a scalar potential function little f such that the given vector field f equals to its gradient. Right. So next what we do is we will find this vector, we will find this scalar potential function f, because if f is a conservative vector field, we should be able to find a scalar function little f so that its gradient equals to the given vector field.